My name is Dabing Yu. I'm really pleased to have this opportunity to share our research, Dual Stream Transformer for Hyperspectral Image Restoration. Hyperspectral image (HSI) collects rich and detailed spectral information, effectively reflecting the subtle spectral difference of different objects. Nevertheless, mainly due to the physical limitations of spectral sensors, it is inevitable to gather degraded hyperspectral images. First, the generated hyperspectral image has a low spatial resolution. The hyperspectral image sensor has to sacrifice spatial resolution to obtain a high spectral resolution with abundant spectral information. Second, the hyperspectral imaging systems scan the object scenes along a spatial or spectral dimension for a long time, inevitably introducing numerous noises. The CNN models only model and analyze limited receptive field, and thus neglect the global contextual information without the ability to model long-range location dependency. As applied to the high-dimensional hyperspectral data, the inherent bias of CNN is magnified. Besides the long-range pixel dependency, global spectral information is equally essential for degraded hyperspectral image restoration. However, Transformer relies on self-attention mechanism to model the global contextual information and has the potential to relieve the aforementioned limitation of CNN-based methods in HSI restoration. Directly applying the transformer can capture spatial interactions but not model the interspectral similarity and correlations. However, global spectral and spatial information are equally important for HSI restoration. Therefore, multi-deconf head spectral attention (MDSA) and multi-head spatial self-attention (MSSA) are applied to separately capture long-range spectrum dependencies and spatial interactions and parallel branches. Transformer exploits enormous amounts of training data to learn the data distribution and future presentation. A limited amount of HSI training examples exacerbate the undesirable behaviors, such as memorization and sensitivity to out-of-distribution samples. We formulate both tasks into the same transformer such that abundant training samples can effectively regularize parameters and achieve excellent performance. Finally, we propose dual-stream transformer DSTrans for hyperspectral image restoration. DSTrans adopts the structure of the double tasks on heterogeneous datasets. Our DSTrans mainly incorporate dual-stream transformer blocks in residual design. We evaluate our DSTrans on benchmark datasets for two HSI restoration tasks, HSI super resolution and HSI denoising. We perform ablation experiments to analyze contribution of all components and the parameter choices. Thank you very much for watching this video.